This is BaslerCast, tutorials for Mr. Basler's physics class. The topic of this video tutorial is an introduction to forces. Let's get started. To begin our discussion about forces, we first begin with a simple question. What is a force? Now, this definition of a force can grow and get more elaborate as this course goes on, but we start off with just a simple definition, which is that a force can be a push or it can be a pull. So that's what I can do to the book. I can push it along, I can pull it along, I could push on it just a little bit but it doesn't move. I can pull it just a little bit but it still doesn't move. But, you know, down to the basics, force is just a push or a pull. We're going to start off with a few different types of forces just to get going. Now, this by no means is all the forces that there are out there. There are different forces that we won't cover right away, but this is an introduction to some of the four common forces that we'll start off with. The most common, I think, that we're all susceptible, that we're all going to experience all the time, unless we go on a big journey, is the force of gravity. The force of gravity, of course, makes things fall, but the force of gravity is also just holding you in your seat or holding you in the couch, pulling you down into that couch, squishing the cushions basically because you're being pulled to the center of the earth. The force of gravity comes from the earth because the earth is a large mass and it attracts other masses, pulling it towards the center of the earth. So that's our first one, kind of our most obvious one. The next force, maybe you heard of, but we don't always talk about it in this way, so let's define the force of tension. Now, the force of tension would be a pulling force, not really a pushing force, because the tension force comes from things like cables, strings, ropes, chains. They're always pulling on something, and so that's what we're going to define as tension forces. Cables, ropes, chains, strings, those pulling forces are going to be called force of tension. The next force is a real culprit when it comes to wanting to move. When we try to move something, we're always hindered by the force of friction. Think of the force of friction as a force that is stealing away energy anytime something begins to move, is moving, or is just moving along, and it just steals away that energy, slows it down, or prohibits it from beginning to move at all. The last force, probably the one you haven't heard of, is the normal force. Now, the term normal just means perpendicular. So over to the right side here we have just a simple diagram of a picture of a table. And perpendicular to this surface, to the top of the table, would be a force coming straight out, straight up. Now, there isn't any force there right now because nothing is pushing down on the table, but the table will push back up if you were to, say, stand on it. And it'll support your weight. So the earth pulls you down with the force of gravity, and the table will push you back up, holding you in place. Of course, the normal force changes as you add different things to the table. So if we were to change the situation, perhaps add something bigger like an elephant on top of the table, now we need more normal force up to hold this elephant in place because it weighs more and gravity is pulling more elephant down. So in this case, this might be a really small elephant or a very sturdy table. To analyze forces and to get a better understanding about what is going on for an object, we take a typical situation. Here is a very basic situation. Here is a box sitting on a table. We know that there are forces acting on this box if it's at rest on a table. We know that gravity pulls the box down, and we know that the table keeps the box where it is by pushing back up onto the box. So one way to analyze or get a better understanding is to draw a force diagram. That is a sketch of these two arrows, the vectors, if you will, off to the side for the object. The dot in the middle represents the center of the box, or the center of any object, and then we draw what forces are acting on the box. So in this case, we have a force down. We'll call that the force of gravity, because we know that gravity is causing it. And next to the symbol F sub g for force of gravity, we have in parentheses some notation. Now, this notation is on by notation. And what it does is it tells us that the force of gravity is acting on B for the box, and it is by E, the earth. The earth is causing the force of gravity. Upward is a normal force. That normal force is equal in size to the force of gravity, and we can see that by the length of the arrows, but opposite in direction. The normal force is B on the box. It's on the box for B for box, and it's by the table, T for table. Now, when these forces are balanced, in the situation we just had with the box on the table, there is no acceleration. The same amount of force down is canceled out by the same amount of force up. So we have no acceleration. Now, what does that mean? Well, be very careful. It means that the box is either at rest or the box is moving at a constant speed. Moving at a constant speed is also no acceleration. It doesn't have to be just sitting there. It could be just moving at a constant speed. What about unbalanced forces? What if the forces are not balanced? In this case, we have more force down than we have force up. In this case, we have overall force down. We call this overall force the net force. Take all your forces, add them up. What do you have overall? In this case, we would have overall more force down than we have up. So we would say we have a net force down. When we have a net force down, then we have a net acceleration down also. We can look closer at balanced and unbalanced forces as I pull a block up using a motor and pulley. To measure the force, I attached a force probe onto the block. The string from the force probe was fed through a pulley mounted to the ceiling. That string was connected to a motor that could be turned on by a switch. Video of the demonstration was captured with a camcorder and synced to the data being collected in Logger Pro. The green line is collected from the motion detector and shows the velocity, and the red line is collected from the force probe, showing the force that's pulling up on the block. The red line shows a flat line, indicating that the forces acting on the block are constant until an acceleration occurs. At the first spike, there is an acceleration caused by more force upward, which makes the block go from rest to moving at some sort of constant velocity. We see another spike after a period of flatness when the block goes from constant velocity back down to rest. This is when it stops, when it's right up at the top. And that's it for our first tutorial on forces. I hope you found it useful, and once again, thanks for watching.